Okay, the Subcommittee on Space will come to order. Without objection, the chair is authorized to declare recesses of the subcommittee at any time. Welcome to today's hearing entitled Charting a Course, Expert Perspectives on NASA's Human Exploration Proposals. And I would like to recognize myself for 5 minutes for an opening statement. Placing a man on the moon and returning him safely is widely considered one of the humanity's greatest achievements. It cemented America's leadership on the world stage and demonstrated our technological superiority during the Cold War. Since then, NASA has made steady progress towards learning to live and work in space with the Space Shuttle and the space station. Today, we find ourselves at an intersection. Do we as a nation retreat from the cosmos, or do we take that next first step into the unknown? There appears to be a consensus that the horizon goal of America's human exploration program is to land on the surface of Mars. But how will we get there? What are the intermediate stepping stones on that pathway to Mars? How do we avoid costly and avoidable detours? How do we ensure a sustainable program rather than a one-off stunt? And how do we ensure the next administration does not wipe the slate clean, erasing all the hard work of the last 5 years? These are all questions that we must address in this and in future hearings. The SLS and Orion systems are critical to the success of our deep space human exploration program. Their development and testing is of the utmost importance to the committee, to Congress, and to the nation. We have come too far now to see a costly and destructive cancellation. However, the use of these assets and the missions and mission sets on the journey to Mars need to be better defined. As the NASA Advisory Council recently stated in a recommendation to the administrator, the absence of a more fully developed plan would impair the ability of the next administration to propose a budget that adequately supports NASA's human exploration program. And while the administration has not provided many details on the plan for the journey to Mars, it has proposed possible mission options. For example, the administration has proposed an asteroid mission as the next step for human exploration. This has been caveated and altered multiple times, but generally speaking, the administration believes human astronauts should interact with an asteroid in cislunar space sometime in the next decade as the next step on its journey to Mars. Despite opposition from space policy experts, scientists, and engineers, the administration as recently as last week announced early design work for the asteroid mission spacecraft bus. With only 9 meaningful months remaining in this administration, it is puzzling that they continue to press ahead with the mission despite widespread criticism and doubt over its efficacy. The National Academy of Sciences released a study on human exploration called The Pathways to Exploration. In this report, the Committee on Human Spaceflight determined that the ARM mission largely contributed to dead-end technologies that could not reasonably feed forward into the human mission to Mars. Last year, the NASA Advisory Committee suggested to the administration, that a more valuable use of NASA's time and money would be a solar electric propulsion demonstration mission to Mars and back, as opposed to the asteroid mission. Alternatives to the asteroid mission proposed by the President have become ubiquitous in the policy discussions. For example, Jan Werner, the European Space Agency Director General, has spent the last year advocating for an international lunar base. The recent Humans Orbiting Mars workshop presented a compelling, realistic, and affordable path to Mars. Also, several members of this committee have suggestions and legislation as well to that effect. As the administration ignores these proposals, despite a groundswell of support from scientists and engineers, we must look beyond what is politically expedient today and to get ready for the next few decades in space flight. As we prepare for the next president's administration, We must ensure that the plan in place for human exploration is based on sound engineering, planning, design, and management principles. We have asked our witnesses today to give us their expert opinions in the way forward. This hearing is an opportunity to build consensus on the way forward for human spaceflight. Human exploration has a long and storied history of being nonpartisan. It is not Republican. It is not Democrat. It is an American issue. We need to get the politics out of these very important programs for our nation's sake. There are thousands of men and women in this country whose days are impacted by the decisions that we make in this very building. It is easy for people confined to the Beltway bubble to forget that our pride as Americans comes from the hard work and determination to make this world better. The men and women at NASA working on our human exploration program are not pawns to be moved around a chessboard in the latest game of chicken that the administration chooses to play with Congress. We must ensure NASA's work focuses on the will of the people, not the political whims of whatever president is in office at that particular time. NASA's human exploration program has been through a tumultuous 7 years. And with a new president to be chosen by the end of this year, we must ensure that there is a constancy of purpose in our planning and a sure-footed roadmap in place for the future. I now recognize the ranking member, the gentlewoman from Maryland, for an opening statement.
Good morning, and thank you very much, Mr. Chairman. I want to welcome our distinguished panel this morning. This truly is my passion. I want to thank Chairman Babin for calling the hearing. I think it's really important, and when I look at the young people out here, not only is it my passion, but it really is your future. And so I think the work that we have to do today is incredibly important. Each time we hold hearings on sending humans to Mars, my colleagues and I don't just leave the room, although today I will have to leave a little bit early. We don't leave the subject behind, and I think that that is meaningful for the American people. Instead, we leave with increased determination to help find a way to get there as soon and as safely as possible. I want the American people to share the collective excitement in this room and to embrace the desire to send human explorers farther into space than ever before. This committee's inquiries during recent hearings have focused on the need for a clearly articulated plan and next steps, such as the Human Exploration Roadmap that the bipartisan, overwhelmingly bipartisan House-passed NASA Authorization Act of 2015 directs NASA to develop. It took a lot of work for all of us to come together as Republicans and Democrats to embrace that roadmap. I recognize that it's not an easy task given previous flat funding levels, uncertainty over future budgets, and the need to allow flexibility in planning a multi-decadal endeavor. I also acknowledge that NASA has established a strategy for achieving the goal and an evolvable Mars campaign that will allow for flexibility in its decisions and that can take advantage of new knowledge and advances in technology. But facets of that strategy, quite frankly, are not detailed enough to inform mission planning and sequencing. That strategy cannot answer questions about whether going to the lunar surface or an asteroid is needed to reduce risk before sending humans to Mars. Nor does it allow us to assess whether NASA's approach achieves the right balance of flexibility and definition. The congressionally mandated National Academy's report, Pathways to Exploration, recommends that NASA follow a pathway, a specific sequence of intermediate accomplishments and destinations that advance the technologies needed to reach the horizon goal, which they conclude is Mars. The NASA Advisory Council, in its December 3, 2015 recommendations to the administrator, said that they were pleased that NASA was providing new information about its human exploration architecture. However, they also recommended that, quote, in preparation for the 2017 transition of administrations, NASA further develop their plan for future human exploration. Well, this is because of the importance of defining a baseline architecture and plan that encompasses the entire human exploration program. Mr. Chairman, I'm confident that a plan of sufficient detail can come to fruition, but we don't have time to spare if we're to sustain a challenging endeavor across the upcoming presidential transition. Now it's time for us to get rid of the politics and actually match our goals with a plan. And without agreement on the substance of a plan, the path forward is less clear, and the sustainability of progress toward the Mars goal is left vulnerable to rehashing of interim destinations or even redirection. We've seen that happen in the past. This last decade, despite the concerns articulated by the chairman, this last decade has been fraught with confusion, both from the Congress, Republicans and Democrats, and Republican and Democratic presidents. And it's time to put that aside so that we can advance the science that's necessary. And make no mistake, we have to do our jobs here in Congress, and we have to be of a mind in providing NASA with the necessary resources and budgetary stability to carry out such a plan. The Congress's recent increase in appropriations for fiscal year 2016 for NASA's exploration systems is a good start, but they need to be sustained and built upon if we're to reach that goal. So, Mr. Chairman, we have a lot to discuss this morning, and I look forward to our witnesses' testimony. And what I would urge us to do is, again, let's just put the politics aside. I agree with the chairman that going to space is not about Republicans and Democrats. And when I look at these young people out here and I see your future and I see the challenge that you're going to take on, you don't care whether it's a D or an R. We care that we advance the science to get us to our goal, and I look forward to doing that. Thank you, Mr. Chairman, and I yield.
Thank you, Ms. Edwards. I appreciate those words. And also would like to welcome all you young folks out there, as well as you not so young folks. We understand, are you all from Florida? Yes. Well, thank you for being here this morning. What'd you say?
Where's Bill Posey?
Louisiana. Okay, well, that's good. Almost to Texas. And speaking of Texas, I now recognize the chairman of the full committee from the great state of Texas, Mr. Lamar, Chairman Lamar Smith.
Thank you, Mr. Chairman. Americans are fascinated by space exploration. It fuels our desire to push the boundaries of what is possible and to reach beyond our own pale blue dot. In the last few years, the flagship deep space exploration programs at NASA, both robotic and human, have been under attack by the Obama administration. This administration canceled the robotic ExoMars mission and the Constellation program, and it continues to propose drastic cuts to the Space Launch System and Orion programs. These programs were all developed to support deep space exploration to destinations like the Moon and Mars. The Obama administration cannot claim that it prioritizes Mars exploration if it refuses to prioritize and support the programs that will get us there. And the budget instability created by the administration makes it hard for NASA to plan and execute critical programs. For example, NASA recently announced that the first crewed mission for SLS and Orion was now delayed by 2 years because the administration would not allow NASA to budget for the programs. While the administration regularly cuts SLS and Orion budget requests, Congress continues to restore those cuts in a bipartisan fashion. And there is bipartisan support within Congress for SLS and the Orion crew vehicle. This committee has restored proposed cuts year after year in our authorization bills. And the House and the Senate Appropriation Committees restored funding for the SLS and Orion at the levels necessary to keep their development on track. The SLS and Orion programs represent what is most impressive about the American spirit, the desire to explore. The technologies that are developed for these programs exemplify our greatest breakthroughs and demonstrate American ingenuity. This committee will not permit this administration to threaten the succession of these programs. Any efforts to cancel these programs will be met with stiff opposition. The administration should develop solid plans for future exploration missions that foster support from the science and engineering communities. However, the administration continues to push plans for an uninspiring and unjustified asteroid retrieval mission. Just last week, NASA announced its strategy to develop the spacecraft bus that will be used for the robotic elements of that mission. The administration continues to force this mission on NASA without any connection to a larger exploration roadmap and absent support from the scientific community or NASA's own advisory committees. This is a misguided mission without a budget, without a launch date and without ties to exploration goals. It is a mission without the support necessary to make it a reality in the 9 months remaining in the Obama administration. It is just a time-wasting distraction, but maybe that is what the administration really wants. Instead, the administration should follow the advice of the NASA Advisory Council and more fully develop its human exploration plans, including a human flyby mission to orbit Mars. There are many options, but without a roadmap to guide the agency, NASA will continue to be subject to indirection and proposed budget cuts by the White House. For its part, Congress will continue to ensure that space exploration will receive the funding needed to stay on schedule and on budget. Great nations do great things. Fortune favors the bold. These next few years are critical. A trip to Mars can turn science fiction into science fact before our eyes and within our lifetimes. The first flag to fly on the surface of Mars should be ours. I hope the administration will join Congress in pursuing that goal. Thank you, Mr. Chairman. I yield back.
Thank you, Mr. Chairman. Appreciate those wise words. Now I recognize the ranking member of the full committee, another person from Texas, Ms. Johnson.
Thank you very much, Mr. Chairman, and good morning to all, and let me welcome our distinguished panel and welcome our young people. I have made it well known that I consider NASA to be a critical national asset. NASA is a source of technological and scientific innovation and an inspiration to generations of young people and a catalyst for economic growth. It is also a positive symbol of American preeminence worldwide and a demonstration of our commitment to the international cooperation in the peaceful uses of outer space. Human exploration is a highly visible facet of NASA's multi-mission portfolio. It is thus appropriate to continue to examine the nation's human exploration strategy. At a June 2014 committee hearing, we heard from the co-chairs of the National Academy's review of the future of human exploration in the United States. That comprehensive review was conducted at Congress's direction. As I said at that time of the hearing, the Academy's report did not mince words. It provided us with an important wake-up call. The report's conclusions were clear. We are not going to have a human space exploration program worthy of this great nation if we continue down the current path of failing to provide resources needed to make real progress and failing to embrace a clear goal and a pathway to achieving that goal. It rests with this committee and Congress, not the White House, on what is authorized and what is appropriated in this Congress. What we need now is a clearly articulated plan on how we will get to Mars and what we call a roadmap in the House-passed 2015 NASA Reauthorization Act, and what the Academy's called a pathway in their report. In just about 1 year, the nation will transition to a new presidential administration. Such transitions have in the past led to significant redirections in NASA's human exploration program. Mr. Chairman, if that were to happen again, that would be a tragedy, and a wasteful one at that. It is Congress's responsibility to listen to the reports and make recommendations and authorizations accordingly. NASA has made significant progress since 2010 NASA Authorization Act was enacted. Fabrication of the Space Launch System is underway. Flight testing of the Orion vehicle is confirming design objectives. Ground systems are being modernized, and ways of mitigating the effects of long-term space travel are the subject of intense research on the International Space Station. In that regard, Mr. Chairman, I hope we can have an opportunity to hear from NASA in the not-too-distant future on the progress of its journey to Mars strategy and how the investments in SLS, Orion, and ISS fit into that strategy. In conclusion, last week we honored the crews of Apollo 1, STS-51L, and STS-107. These brave men and women paid the ultimate price while furthering the course of exploration and discovery. We as a nation owe it to them to continue this grand journey of exploration of the universe. Future generations of Americans depend on us. We cannot blame anybody else but us. We must not let the nation down. We must not let our young people down. I thank you and yield back.
Thank you, Ranking Member Johnson. Now let me introduce our worthy and expert witnesses at this time. Mr. Tom Young, former director of NASA's Goddard Space Flight Center, former president and chief operating officer of Martin Mariana Corporation, and former chairman of SAIC. Mr. Young joined NASA in 1961 as a member of the Lunar Orbiter Project Team and was mission director for the program Viking. Prior to being named director of Goddard Space Flight Center, Mr. Young was director of the planetary program at NASA headquarters and deputy director of the Ames Research Center. Mr. Young earned a Bachelor of Aeronautical Engineering degree and a Bachelor of Mechanical Engineering degree in 1961 from the University of Virginia. In 1972, he received a Master's of Management degree from MIT. Dr. John Summerer is our second witness. Dr. Summerer is a technologist, with over 35 years of professional experience and over 20 years of executive experience. He chaired the technical panel of the Pathways to Exploration report at the National Academy of Sciences. Dr. Summerer received his BS and MS degrees in systems science and mathematics from Washington University in St. Louis, an MS in applied physics from Johns Hopkins University, and his PhD in physics from the University of Maryland. Dr. Spudis is our final witness today. Dr. Paul Spudis is a senior staff scientist at the Lunar and Planetary Institute in Houston, Texas. At LPI, Dr. Spudis' research focuses on the geological processes of the terrestrial planets and the study of the requirements for sustainable human presence on the moon. He is the recipient of numerous awards and has authored or co-authored over 100 scientific papers and 7 books. Dr. Spudis received his BS and his PhD from Arizona State University and his Master of Science from Brown University. I want to tell you how appreciative we are that you three illustrious gentlemen have come to speak with us today. I would now like to recognize Mr. Young for 5 minutes to present his testimony.
Chairman Babin, Ranking Member Edwards, and committee members, I'm pleased to have the opportunity to present my views on the United States Human Spaceflight Program. While I'm a member of the NASA Advisory Council, my participation in the hearing today is as an individual representing only myself. The United States Human Spaceflight Program, from Alan Shepard's initial suborbital flight and John Glenn's orbital flight to today's International Space Station, has been rich in exploration excitement, scientific return, and technological accomplishments. The success of the human spaceflight program for over 5 decades can be traced to many factors. Clearly, the integration of the extraordinary NASA capabilities with the exceptional implementation capabilities of industry has been a major factor. NASA alone, or industry alone, could not have been successful. This is an important lesson as we plan for the future. Today, the future of the human spaceflight program is far from clear. We know some critical parts of the puzzle, including the ISS, commercial cargo, commercial crew, SLS, and Orion. There are many pieces that are yet to be defined and funded. These include a habitat module, landing systems, a solar electric propulsion tug, and a launch system for return from the surface of the Moon or Mars. We have continual debate as to whether our goal should be the Moon, Mars, or both. We have a 2016 budget that allocates approximately $9 billion for human spaceflight. The budget is divided roughly equal between LEO and exploration. What we do not have is a plan, strategy, or architecture with sufficient detail that takes us from today to humans on the surface of Mars or the Moon with a long-term goal of extended presence. I would like to offer my views on the existing and missing pieces of the puzzle, starting with the budget. If the 2016 amount of $9 billion remains constant with the addition of inflation for the next 2 decades, there will be approximately $180 billion with today's buying power available. With that level of funding, significant progress can be made on a human exploration program. A study to define minimal architecture for human journeys to Mars, initiated by Scott Hubbard and conducted at the Jet Propulsion Laboratory, provides a credible argument that a Mars mission is feasible at these funding levels. I personally believe increasing the budget will be necessary to support a comprehensive program that includes appropriate precursor activities and missions to realize a responsible funding level for exploration. It's necessary also to make decisions between low Earth orbit and activities in low Earth orbit, and to have a well-defined, highly focused plan that includes only those activities necessary for the success of the endeavor. Currently, the human spaceflight budget supports both a LEO program consisting of ISS, commercial cargo, and commercial crew, and an exploration program consisting of SLS, Orion, and other exploration activities. Future budgets will be required to support the additional required pieces of the puzzle that I discussed earlier. The combination of the current LEO program and the desired exploration program are not affordable at current budget levels. A choice is required between the two programs. A sustainable exploration program requires that the necessary knowledge from ISS be obtained expeditiously, followed by diverting current ISS funds to exploration. An alternative is to continue funding the LEO program and forego a credible Moon or Mars exploration program that results in the humans on the surface within a reasonable schedule and budget. We cannot do both without a major augmentation of the budget. NASA's done an excellent job maintaining a conservative cargo transportation capability. This conservative approach allows a mission failure or multiple failures to occur without catastrophic consequences. It also allows a management approach that relies heavily on the commercial partner with modest NASA involvement. Commercial crew is much more challenging. A commercial crew failure that involves loss of the crew will be a catastrophe. This recognition requires commercial crew to be managed significantly different than cargo. Commercial crew requires the full application of the NASA human spaceflight expertise in combination with the extraordinary implementation capability of industry to assure an acceptable probability of success. The concept often stated to let the commercial world be responsible for LEO activities with NASA responsible for exploration is not valid for commercial crew. The next topic I would like to address is the Moon-Mars debate. Each option has merit. While a human to the Moon program is highly challenging, a human to Mars program is much more difficult, challenging, and costly. This latter factor must be taken into consideration in the debate. My opinion is that Mars is a much more compelling option. I believe NASA, the current administration, and the House in the NASA Authorization Act of 2014-15 have settled upon the human to Mars option. It is clear again that we cannot do both, and there is a need to focus our attention, capabilities, and resources upon one option. For the remainder of my comments, I assume the humans to the surface of Mars option to be the choice. In my view, a plan is required for the following reasons. One, A plan is required for the implementation team to have a common focus. A plan is necessary to obtain program support. Without a plan, constituents cannot make an evaluation and know if they're supportive. A new administration will be in place in about a year. Without a plan, it will be difficult to obtain support and avoid another redo of the content and focus of the United States Human Spaceflight Program. A plan is necessary to effectively define required technologies, including the level and schedule. A plan is necessary to effectively define supporting information needed from ISS and NASA science program. A plan is necessary to identify the approximate level of required resources. A plan is necessary to assure resources are applied in the most effective manner. A plan is necessary to define precursor missions that should be planned and implemented. A plan is necessary to define the cislunar space proving ground activity that is currently evolving. It is important to do what is required for a successful exploration program and not what is possible. A plan is necessary to effectively assess risk and develop mitigation plans. An argument against a plan at the current time is that we are not ready to finalize the necessary elements of the plan. I believe a strength of NASA program management is to establish a plan relatively early with the recognition that as new information becomes available, the plan can be changed. I believe we have the opportunity to set a direction for the United States Human Exploration Program that is exciting, realistic, inspiring, and sustainable. I believe the most compelling case is for the humans to the surface of Mars option. Decisions are required relative to LEO if a vigorous exploration program is to be pursued. This includes the future of ISS and commercial crew. Preparation is required for the transition to the new administration. A plan in sufficient detail to maximize the probability of support and sustainability is required. Above all else, a plan with significant detail that takes us from today to humans on the surface of Mars is required. Thank you.
Thank you. Thank you very much, Mr. Young. I now recognize Dr. Summer for 5 minutes to present his testimony.
Chairman Babin, Ranking Member Edwards, and distinguished members of the subcommittee, thank you for the opportunity to discuss the options for architectures and intermediate steps to develop the capability to send humans to Mars while maintaining constancy of purpose through the next and necessarily many subsequent administrations. I had the privilege of chairing the technical panel of the congressionally mandated National Research Council Committee on Human Spaceflight, and I'm here to represent some of the salient features of that panel's conclusions about possible pathways to Mars, as well as some of my own views. The first and by far the most significant conclusion is that while sending humans to Mars and returning them safely to Earth may be technically feasible, it is an extraordinarily challenging goal from physiological, technical, and programmatic standpoints. And because of this extreme difficulty, it is only with unprecedented cumulative investment and, frankly, unprecedented discipline in development, testing, execution, and leadership that this enterprise is likely to be successful. To be explicit and to set the scale of the problem, the technical panel, aided by independent cost estimation contractors and using a process that respected the importance of development risks, technical challenges, capability gaps, regulatory challenges, and programmatic factors, as well as the need to maintain a reasonable operational tempo, concluded that the first crewed Mars landing might be possible 20 to 40 years from now after a cumulative expenditure on the order of $500 billion. The actual time frame and cost will depend greatly on the pathway chosen to achieve the goal, and candidly, the fastest and least expensive pathway that we examine comes with enormous risks to both the success of the missions and the lives of the astronauts conducting them. Let me briefly and very superficially review the most significant risks of attempting to send humans exploring in deep space. We know that prolonged exposure of astronauts to the space environment has the potential to harm them. Astronauts on long missions, such as we are conducting now on ISS and have been conducted by the Soviets in the past with Mir, have experienced potentially debilitating effects caused by the microgravity environment. Musculoskeletal deterioration has been the best studied, and while exercise has the potential to mitigate its impact, the regimen needed over the duration of a human mission to Mars may not be realistic. The radiation environment in space, especially deep space beyond the protection of the Earth's magnetic field, has been quantified largely in terms of increased cancer risk due to galactic cosmic rays, against which shielding is ineffective without prohibitive mass penalties. However, the non-carcinogenic risks due to radiation, such as cumulative neural degeneration, are much less well understood and may well prove to be more limiting. It appears that with existing architectures for Mars missions, which include greater than 1 year stays on the Martian surface, which brings with it its own risks, physiological limits may not be prohibitive, although risks to astronauts would be very high. Long-duration orbital missions at Mars or on Mars moons may not be feasible at all because of radiation. Few of the technological challenges of a crewed Mars mission are insurmountable, but cumulatively they represent a huge gap relative to our current capabilities and our current available resources. The committee's final report includes a list of 15 high-priority technical capabilities, and most of the intersections of those capabilities against the various forms of challenge are red in risk assessment. Things such as there's no technical solution known, there's no such system that's ever been developed at the necessary scale. Current regulations impose significant challenges and will be difficult to change, and development to operational capabilities on the order of previous large national programs. In short, there's an awful lot of technical work to do. Having spent my life as a technologist, I can say that a large job list isn't altogether a bad thing, but it does require a great deal of discipline and a certain ruthlessness in pruning efforts that are not making needed progress or that don't accumulate to the intended goal. I applaud the fact that with this committee's and the administration appropriators' help, NASA finally has a Space Technology Mission Directorate, which has recently made some significant contributions to the capabilities that my panel identified as highest priority. However, in other areas that the panel identified as highest priority, such as in-space power and propulsion, NASA appears to be maintaining the entire trade space of possible propulsion challenges. SLS and Orion aren't the only things we'll need to get to Mars. I also wish to note that one of the foundational conclusions of the technical panel is there's a very limited set of places for humans in the solar system for the foreseeable future, given what we know about technology and physiology. We've been to the moon, so we know that's possible. We probably can go to some near-Earth asteroids, and as we've discussed already today, maybe we can get to Mars. Given the relative simplicity of the field of regard, there are tremendous technical and programmatic advantages to deciding once and for all where we're going and in what order. Each of these possible destinations has proponents to be what's next, but given the size of the job jar, it's not helpful to keep changing our minds. The NRC committee advocated that a defined pathway with missions to the different possible destinations in sequence has some highly desirable properties, such as that the sequence of missions and destinations permits stakeholders to see progress, that the pathway has a logical feed forward of technical capabilities, that the pathway minimizes the use of dead-end systems and equipment, that the pathway is affordable without incurring unacceptable development risk, and the pathway supports, in the context of the available budget, a reasonable operational tempo. The NRC did not recommend any particular pathway, but did assess 3 notional pathways against these attributes. The committee noted that the notional pathway that is closest to NASA's current plans has serious deficiencies with regard to the significance of the intermediate destinations, logical feed forward, the number of dead-end systems, and exceedingly high development risk. The committee also noted the 2 alternative pathways that did not have these deficiencies failed against the affordability and operational tempo attributes at current expenditure levels. To quote the technical panel's final briefing to the entire NRC committee in 2013, in the current fiscal environment, there are no good pathways to Mars. So I'd like to conclude briefly with some of my own views. I understand that there is bipartisan support for a go-as-we-pay approach to human spaceflight. But just as it is not feasible to take a cross-country trip on a child's allowance because of thresholds cost, we may well never be able to get to Mars at current expenditure levels. It might be better to stop talking about Mars if there is no appetite in Congress and the administration for higher human spaceflight budgets, and no willingness to cut programs that do not contribute to progress. At a minimum, we should agree on a pathway that is satisfying to the public, even if it does not lead to Mars in the foreseeable future. A pathway that includes the surface of the Moon is one obvious possibility. Thank you.
Yes, sir. Thank you, Dr. Summer. Those interesting words. I now recognize Dr. Sputis for 5 minutes to present his testimony.
Thank you, Mr. Chairman. I thank the committee for this opportunity to give you my thoughts on our nation's program for human exploration of space. This testimony is my personal opinion and does not necessarily represent the views of my employer, the University Space Research Association. America's space program is in disarray. We pretend that we're on a journey to Mars, but in fact possess neither the technology nor the economic resources necessary to undertake a human Mars mission now or within the foreseeable future. What we need is a logically arranged set of short-term, realizable space goals that are not only interesting in and of themselves, but whose attainment will build capability in the long term. Whatever goals are selected, significant milestones must be reachable on a regular and recurring basis. Only in such a program can progress be mapped and resources allocated accordingly. Thus, any program to extend human reach beyond low Earth orbit must be incremental, with each step small and affordable, yet cumulative, so the smaller steps integrate into a larger coherent program. In 2010, the United States abandoned the goal of lunar return set by the Vision for Space Exploration. Congress directed the agency to continue building the Orion spacecraft and to develop a new heavy-lift launch vehicle, the Space Launch System. As derivatives of the canceled Project Constellation, the new systems are optimized for missions to cislunar space, the zone of space between low Earth orbit and the lunar surface. To replace the Moon as a destination, several near-Earth asteroids were examined, but for various reasons, all were found to be unattainable. Instead, NASA embraced the idea of bringing a small asteroid back to cislunar space, where the Orion spacecraft could visit it, the so-called asteroid retrieval mission. This idea was neither fully developed conceptually nor vetted through the scientific and engineering advisory structures that we maintain to review and judge mission concept proposals. As study of the asteroid retrieval concept has proceeded, the planned size of the return object has continually decreased. Initially, it was planned to return an asteroid about 7 meters across. It's currently planned only to return a small 1 to 2 meter boulder. More than 85% of all near-Earth asteroids are ordinary chondrites, a rock type so renowned for its uniformity that it is used as a compositional standard in cosmochemical studies. And we already possess tons of this material, as ordinary chondrites continually fall onto the Earth's surface every day. As a result of the limited power and minimal loiter time, the Orion spacecraft does not possess the capabilities necessary to experiment with extracting useful resources from the asteroid. So the asteroid retrieval mission does not contribute to our learning how to process and use the material resources of space. The microgravity of the arm will not prepare us for human operations on the surface of Mars, which has approximately 1/3 the gravity of the Earth. The arm offers no unique benefits beyond providing a place for Orion to visit. In terms of scientific and operational importance, it is barren of real accomplishment and irrelevant to future deep space human missions. As for learning how to use space resources, it can only perform rudimentary reconnaissance of the type already accomplished or planned by a variety of robotic missions. Although it is claimed that the arm develops technology needed for future Mars missions, specifically the high-power solar electric propulsion unit, missions to cislunar space can develop many of these technologies just as well, and at the same time, in place space-based infrastructure for future use. Cislunar space, the space between Earth and Moon, is home to 95% of our scientific, economic, and national security assets, satellites upon which we are critically dependent. We can only reach these various orbital levels with unmanned systems. When a satellite becomes obsolete or stops functioning, the only solution is replacement. If we could move people and machines throughout the various locales of cislunar space, we would be able to emplace, construct, and upgrade and maintain these satellites. To create this routine access to cislunar space, we should develop a permanent spacefaring infrastructure, including transport vehicles, staging nodes, deep space habitats, power stations, and fuel depots. In terms of the energy expended, all destinations in cislunar are essentially equal. If we can go to and from the moon, we can go to and from all the other localities of cislunar space. Such a system creates not only routine access to the moon, but to all of cislunar space, and it enables human missions to the planets beyond. To develop the system, it is vital that we learn how to harvest the material and energy resources of space. Such technology allows us to launch only the most technically advanced and critical equipment from the Earth, while large mass, low information materials such as propellant and life support consumables can be obtained from local sources. Thanks to a variety of robotic missions over the last decade, we now know that the moon possesses these resources in abundance. The poles of the moon contain billions of tons of water. In its liquid form, this can support human life, and when broken down into its component hydrogen and oxygen, it is the most powerful chemical rocket propellant known. The United States thinks of itself as a world leader in space, but our current lack of focus and strategic confusion undermine that claim. There is interest from Europe, India, Russia, and China in lunar missions. These efforts are not undertaken merely to plant flags on another world, but to reap the benefits offered by the exploration and utilization of the moon. As the world beats a path to the moon, we stand aside. How can we claim technological and scientific leadership in space when we shy from participation and seek no ownership in this arena of cislunar space? But there is another dimension to our abdication of leadership. China is rapidly developing the capability to travel throughout, loiter within, and intercept any target in cislunar space. They have also demonstrated an advanced anti-satellite warfare capability, most notoriously with their interception and destruction of a target satellite in low Earth orbit in 2007. Future Chinese anti-satellites loitering at an L point in cislunar space could fly from the vicinity of the moon down to lower orbits, an approach direction that's not normally monitored, and disable the satellites of other nations. In such a scenario, we would be left with a decided disadvantage as a result of our lack of commitment to the establishment of a strong national presence in cislunar space. America is at a critical juncture in the history of its space program. Congressional leadership is needed to set us on the correct strategic path. The development of the moon and cislunar space answers important national needs. It is an incremental, affordable, and useful direction, a sustainable path that creates new capabilities in spacefaring. A return to the lunar surface allows us to use the enabling asset of the moon to journey to and explore the planets beyond. I thank the committee for its attention. I welcome your comments and thoughts, and I'm happy to answer any questions you might have.
Thank you, Dr. Spudis, for those wise words. Now, the chair now recognizes himself for 5 minutes for questioning. The first one I'd like to direct to Dr. Spudis. Your testimony highlights the need for a sustainable program rather than one-off stunts, something that you have long espoused. In reference to ARMED, A-R-M, your testimony also states that in terms of scientific and operational importance, it is barren of real development and irrelevant to future human deep space missions. Does ARM fit into the stunt category, or is it in the sustainable category?
Well, as put that way, I believe it falls into the stunt category. I don't think that it necessarily leads on to any permanent creation of capability, and that's what's needed. We need to approach the development of cislunar in a strategic manner, so you have small pieces that build upon themselves to a larger whole purpose. And performing the ARM doesn't really gain you anything. It demonstrates that you can do it, and that's about it.
Okay. And Mr. Young, you testified that a new administration will be in place in about a year, and that without a plan, it will be very difficult to obtain support and avoid another redo of the context of our U.S. human spaceflight program. Will you please address the challenge of maintaining continuity for NASA's human exploration program, particularly during administration changes, and what recommendations do you have to address this issue?
It's quite a good question. My first comment is it's hard to sell a plan until you have a plan. So that's kind of step one in the process, in my view. My other comment is it's not just any plan. You know, it's a plan that people, both pro and con, can recognize it as credible. And I think the ingredients of the plan really exist. One is, as I stated, I think there's a reasonable probability over the next 2 decades we'll spend $180 billion on human exploration. That's not a bad down payment. And so, in my view, that needs to be a critical part of the plan. I do think that'll have to be augmented. The second thing that I think is really important is to recognize that there is limits, that there is an interest horizon. There's a limit to how long you can hold out the ultimate goal and expect people to be excited about it. Now, I think we could all debate what that is, but I want to throw out for something like going to Mars 2 decades. I personally think if it's much beyond 2 decades, sustainability is pretty difficult. Somebody may say, no, it's a decade and a half, but I will throw out 2 decades. So I think the plan has to recognize that within like a 2-decade time period, accomplishments at Mars, if that's our goal, really need to be happening. I think the other thing that needs to be recognized is that a plan encompasses leadership, and leadership is about making choices. And I think we have to make choices between LEO and the exploration program. I think we have to make choices between the moon and Mars, as the objective. So my argument is that if a credible plan can put together that has a reasonable time frame, that makes incredibly efficient use of expected resources, if it's done in a manner that makes hard choices, then I think you have the groundwork or the basic input in order to be able to argue with the next administration as to why this should be the sustained activity that should be the focus of the United States human space program. The corollary is, without it, I don't think you have a chance.
Thank you, Mr. Young. For my final question, directed to Mr. Spudis again, or Dr. Spudis, excuse me. Your testimony mentioned that Europe, India, Russia, and China have all planned missions to the surface of the moon in recent years. You also state that as the world beats a path to the moon, we stand aside. How can we claim leadership in a technological and scientific movement in which we have no participation and seek no ownership? In 2010, President Obama attempted to cancel deep space exploration and a return to the moon by flippantly stating, "We've been there before." Thankfully, Presidents Eisenhower and Kennedy did not take the same tack and wash their hands of space exploration after we successfully placed a satellite in space, a human in space, a human in orbit, and a human on the moon surface. Congress rightfully rebuked President Obama's attempt to cancel deep space exploration with the passage of the NASA Authorization Act of 2010. And as we transition to a new administration, what recommendations do you have for maintaining our leadership in space?
Well, I believe that it was a mistake to remove the moon from the critical path, because the moon basically offers us the opportunity to create capability. And in fact, that's why it was part of the vision for space exploration to begin with. The moon is reachable, it's close, it's interesting, and it's useful. It's close enough so that you can send a vehicle to the moon anytime. It's scientifically interesting in that you can address a lot of problems of wide discipline through lunar science studies and scientific studies undertaken on and near the moon. But most importantly, in fact, this is, I think, is the critical thing they realize about the moon, is that it is an enabling asset. It's useful. And we have since found in a variety of robotic missions that there is enormous quantities of water in the form of ice at the poles of the moon. Water is the most useful substance you can have in space. It supports human life. It can be used as rocket propellant. It can be used as radiation shielding. It can be used as a medium for energy storage. So it's an extremely useful substance to have, and it's very heavy. And to launch it out of the Earth's gravity well, which is the deepest gravity well in the inner solar system, basically requires a lot of power, and that's why we need heavy lift vehicles. By going to the moon and developing those resources, you can actually create those capabilities by using the local materials that you find there.
Thank you, Dr. Sputus. Appreciate that. I now recognize the gentleman from Colorado, Mr. Perlmutter.
Thank you, Mr. Chair. And panel, thank you all for being here. So we had a bunch of students. Do we have any students left in the audience? Are you guys students? Where do you go to school? And what year are you? And how old are you? Okay, so you're 24. 24 plus 17, you'd be 41 when this is when we should get to Mars. And we had testimony, Dr. Summerer, I think in December, maybe it was in November, from another panel that said that from an engineering and an astronomy standpoint, that the planets line up in 2033 to make it feasible for us to land astronauts on the moon. And so, pardon me, on Mars. And so we put this bumper sticker together that says 2033, and on the bottom, we can do this. And I know, speaking as one, but having listened to other members of this committee, that Mars is this aspirational challenge that, sparks something in us. And Mr. Young, you're right. If it's, 2 centuries from now, we're all long gone. But this young woman, she could be an astronaut and set foot on Mars at that time. So here are my questions. And I don't think, Dr. Sputus, your testimony is, contrary to getting us to Mars. It could be that the way you put the building blocks together, moon is a key piece of this. And there is no question that it's going to take extreme commitment and extreme understanding to be able to do this well. Our job up here, and this is a quote that I got from astronaut Terry Virts, getting to Mars is not a question of rocket science, but political science. So Dr. Summerer, I'm going to start with you. You said that in your research and the panel's investigation that this was 20 to 40 years and at least $500 billion. How did you come to that?
First of all, I don't want to get into specious precision about $500 billion. It's on the order of $500 billion. Maybe we
Fine.
get by with $180 billion. I don't
But it's
think
a
so.
lot.
Yeah, it's a lot of money. And the reason is, by the way, the planets line up every 2 years, basically, for Mars. So, 2033 is a nice round number to have in mind, but, it could be 2 years after that, could be 10 years after that. There's a lot of stuff you need to get people to Mars and bring them back. We need to have a long-term way of keeping them healthy on the way there. They need to spend time on the surface in a potentially hazardous chemical environment. We need to be able to launch them. We need to have pre-position things that will keep them alive and make it possible to launch them. These are very complicated systems. We can learn a lot in cislunar space. We could have people 3 days away so that if something went wrong with their long-term life support system, we'd have a chance of getting them back, as indeed we did with Apollo 13. But if they're halfway to Mars and something goes wrong because we don't have the experience or we tried to do it a little too fast or a little too cheap, those people are gone.
But if you had,
So let me.
if we somehow, Democrats, Republicans, Congress, and the administrations, and I figure there are going to be at least 5 presidential elections between now and 2033, and I'm happy to give you one of these bumper stickers. And there are going to be 10 congressional elections between now and then. But if we somehow all came together, said, okay, we're going to put a % of the entire federal budget towards getting us to Mars, and that gets you $200, $300 billion over the course of the next 17 years. Can we do this?
Yes, But it takes, as Mr. Young has already said, a plan, what we're going to do, what we're not going to do. Do the things that are necessary in a logical feed-forward way from the standpoint of technology. Don't do
Okay,
everything
I'm
because
just
you
a
got
lawyer,
the stuff
all right?
together.
I'm just a lawyer, and on my senior partner had this little thing he put on our desks. Begin. The rest is easy, and then parentheses, maybe. Okay? If we were to give you a date that had some legitimate basis in science, 2033, because the planets line up right, can the scientists and the engineers and the technologists build us a program that gets us there by 2033?
If you give them the date and the money and help with the discipline, the answer is yes.
Okay.
If any of those three things is missing, the answer is almost certainly no.
Thank you. I yield back to the chair.
I'd like to now recognize the gentleman from Oklahoma, Mr. Lucas.
Thank you, Mr. Chairman. And our friends on the panel, I think we probably have a number of versions of the same question here, and all of you have been before panels before, you understand that's the nature of the body. But as we try to address the issues, I'd turn first, Mr. Young, to you. In just 2 years, the United States will have the ability to return the moon with a space launch system in Orion for the first time in 40 years, and for the first time ever go deeper into space, providing a historic opportunity for American leadership and exploration. Recently, of course, the NASA administrator has stated that NASA would be doomed if the next president changes course and deviates from the developments of the space launch system in Orion. And if you could, one more time, to reinforce the point, discuss with us the risks there are in walking away from the investments made in these programs over the last decade.
First, and I think it's your point, there are no goals that involve human exploration that are significant that are not going to bridge administrations today. So that's a fact that we're going to have to deal with. And so with that, a little bit repeating myself, but it says that we need to, the current administration needs to approach very seriously the transition to the next administration in getting forward the rationale as to why sustaining the endeavor across the administration is an important thing to do. As you're saying, what are the downside if you don't do that? I talked about this $180 billion, and I don't mean to treat that frivolously at all, and I also don't mean to say that's everything that's needed, but it's reasonably logical that the activity will be sustained over the next couple of decades at that level. It would be such a shame if what we did was just waste that money and not having a sustainable program really is wasted. I mean, we have a graveyard today that's fairly extensive that has headstones of human spaceflight programs that consumed a lot of resources and ended up with no basic product. And I don't think we need any more headstones in that cemetery. What we really need is monuments to accomplishments.
Well put, Mr. Young. One more question. Part of your testimony indicated that the recent Human Orbiting Mars workshop organized by the Planetary Society, the Space Policy Institute, and the Jet Propulsion Laboratory provides a credible argument that a Mars mission is feasible at constant funding levels. Is there any reason that NASA could not use that as a baseline to plan against? To expand just a little more, sir.
Yeah, well, I was not a part of that activity, by the way. I'm familiar with it, and I think that what that really accomplished, and what they focused on was a minimum mission, what they were trying to find, a minimum credible mission. But I think the real contribution of that endeavor was they got on the table, on the agenda, a model, or not a model, a plan that most people think has some credibility relative to it to begin the process. Now, the pathway activity that the Congress initiated and was done by the National Academy, did a similar thing. As it turns out, the budgeting, or I don't know if the budgeting is the right way to say it, the cost estimating activity that was done for this minimal mission you referred to was done by the same people with the same process as was done for the pathway activity. So my belief is there are two options that have a lot of basis behind them. They probably neither one are the option that the country will converge upon, but we should put those on the table, and we really should charge the leadership of this country to say, look, you know, if we're really serious about humans to Mars, we've got to have a plan. And, you know, and here are a couple versions that says it's not impossible to have a plan. It's not impossible to have a good plan. But what we've got to do is to converge on a plan that those who are charged with executing the plan really have, you know, have their own analysis involved in and their own recognition of the importance of the plan.
Thank you, Mr. Young. And Mr. Chairman, I yield back the balance of my time.
Yes, sir, thank you. Mr. Perlmutter, you had actually asked a question of one of my interns back there. That's Alexandra Abney. She's a Texas Aggie, and we're very happy to have her working in our office.
Maybe she sets foot on Mars.
She might do that. I'm not sure you and I will be around, though.
Well, that's, yeah. So carry it on.
All right. Okay. Well, thank you. I'd now like to call on the gentleman from Texas, Mr. Vesey.
Thank you very much, Mr. Chairman. And I wanted to ask the panelists about partnerships and where would international and commercial partnership for human exploration in Mars make the most sense?
Mr. Young has already talked to the very effective partnership that NASA has had with industry in achieving our exploration goals to date, and that needs to continue. You can't turn it over to industry. You can't just have it done by NASA in-house centers, I think. International partnership, the technical panel, which I led, was very explicit that that could be a good thing from the standpoint of sustaining commitment. It's credited as one of the things that sustained ISS through some particularly dark times. But what it probably doesn't do is save a lot of money. Something like 15% of the cost of ISS was borne by our international partners, and the rest was paid for by U.S. tax dollars. You would have to have unprecedented levels of international contribution financially to substantially lower the burden on U.S. funding to go anywhere significant. But doing it collectively as a human species, as opposed to a set of countries, makes a great deal of sense scientifically from the standpoint of soft geopolitics, if you will, and other reasons. So commercial space entities will always be a part of the NASA program. I think that's necessary, but turning it over to them, I don't think makes a lot of sense.
Are there international partners that we have already identified or that NASA has already identified that we've already begun to have very strong talks with to sort of start laying the foundation for future travel to Mars?
I'm not in the administration, so I don't know. Okay, I am a member of an International Academy of Astronautics. There's robust discussion amongst technologists and scientists in that group and in its various conferences. But, you know, in terms of actual partners, I presume that we think that the ISS coalition will continue in some form with exploration. Europe has already expressed an interest in a lunar base. There are other significant players out there and some emerging players, and, you know, that's above my pay grade to say whether we should be involved with China or Russia.
Right. Yes, sir.
I'd like to point out that, in fact, there's already international participation in the Orion SLS system because the Europeans are building the service module for Orion, and Orion cannot do anything unless it has a service module. One of the things that could have been looked at that wasn't in 2010 when the moon, return to the moon was dropped, was getting an international partner to help us build the Altair. The argument of the Augustine Committee was that we couldn't afford to build both the Orion and the Altair. The Altair is the lunar lander part of the constellation system at the same time. But it was not explored to look at the possibility of having an international participation in the building of the lander. So in actual fact, if Orion and SLS is the future of human spaceflight, we already have international participation.
Thank you, Mr. Chairman. I appreciate it. I yield back my time.
Yes, sir. Thank you.
Thank you.
Let's see, I'd now like to recognize the gentleman from Alabama, Mr. Brooks.
Thank you, Mr. Chairman. I don't know if you're familiar with the economic news for America that's come out recently, particularly with respect to our deficit and debt, but it's taken a decided turn for the worst. The first quarter numbers reflect that our revenues went up 4%, but our spending went up 7%. According to the Congressional Budget Office, relying on Treasury Department numbers, our first quarter deficit was $36 billion worse in this fiscal year compared to the previous fiscal year. If that were extrapolated out, that would mean that our deficit has gone up $144 billion worse this year than the previous fiscal year, although the CBO projects that it will probably be more likely in the $130-something billion range worse. The CBO is also projecting that our total amount of debt is now going to blow through the $30 trillion mark within a decade. And the real question is whether America is going to be able to survive that, whether we will go through a debilitating insolvency and bankruptcy. So with that as a little bit of an economic background as to our country's finances, my question to you is, how do we avoid a repeat of the Constellation program's demise in 2010 at the hands of the Obama administration? And a corollary to that is, what lessons did we learn, and how can we apply what we learned to the Space Launch System and the Orion programs? The floor is yours.
I'll take a crack. The budget numbers that you talked about, the economic numbers, are sobering. So I don't want to, dismiss them at all. If I would look at myself personally, I would call myself a fiscal conservative. So I worry about those kinds of numbers. I equally worry about what great nations do. And I think great nations do great things. And so I think that relative to the country as a whole, as we go through challenging economic times or challenging whatever times there may be, I think that we are fortunate that we live in a country that has the ability to also do great things while we're meeting these challenges. So I put myself in that category of advocating working today's problem and planning for great things for the future. Relative again, and I'm being a little bit redundant, nothing troubles me more than to spend a reasonable amount of money, to come back to maybe my crazy analogy earlier, for another tombstone. And that's why I personally am passionate about humans to Mars, but I'm equally passionate about a good, disciplined plan that is not frivolous. And one of my colleagues commented, a plan that does what is required, but is also does not do what is not required, or maybe another way to say it, doesn't just do what is possible. So a disciplined, structured plan that accomplishes what I'm calling what a great nation does a great thing is important. And maybe naive, but it's my belief that such a plan, well constructed in a bipartisan, I guess, kind of an effort, I think that kind of a plan should be stable across administrations. And if we as a country can't do things like that across administrations, when they're well thought out and well done, then shame on us.
Mr. Young, let me please interrupt. We're running short of time, so if either of the other two gentlemen would also like to respond, please feel free to do so.
Well, I'd like to reiterate Mr. Young's point that probably we're going to spend $180 billion on human space flight in the country over the coming horizons unless that just stops altogether. Let's spend the money as wisely as we can. You could make an argument, and some do, and I have from time to time, that maybe we shouldn't have human space flight, that we ought to rely entirely on robotic probes, which are much more cost-effective for the scientific knowledge that's adduced. That's a choice that in really grim financial straits the country might be forced to make. But it doesn't seem to be something that people want to stand up and proudly say, let's end the human space endeavor and rely on only robots. Although the robots stuff is pretty cool. Mars, Pluto, etc.
I'll make this very brief, but we're compelled to be present in space for a variety of reasons. Modern civilization critically depends on the assets in cislunar space. So what I've tried to envision is a way to make the human program relevant to those critical needs. And what I've identified is the fact that if you go to the moon and develop its resources to create a permanent transportation system that can access not only low Earth orbit, but all the points in between Earth and moon, you've actually created a system that can not only maintain those critical space assets that we use every day, but also inherently gives you the ability to go to the planets when you have that. So I am cognizant of the fact that we're in serious fiscal trouble. We've been in serious fiscal trouble for my entire adult life, but we've continued to spend money on space. We just haven't spent it in a focused manner with a clear strategic direction, and I think that's what's needed.
Thank you, Mr. Chairman. Thank you, witnesses.
Thank you, Mr. Brooks. Mr. Posey is not here, so we will go to the gentleman from Oklahoma, Mr. Bridenstine.
Thank you, Mr. Chairman. I'd like to, number one, thank you, Dr. Spudis, for your testimony. You mentioned three things I'd like to hit on. Number one, you talked about three specific missions: cislunar habitats, resource extraction from celestial bodies, and rendezvous and proximity operations as it relates to doing servicing of satellites. And you were specifically talking about the human components of each of those. And I would like to bring up an issue that I think is important that we need to be talking about here on this committee, and that is this: that there are commercial entities raising private capital right now that are capable of doing these missions, willing to do these missions, and these private companies. The risk is no longer raising capital. The risk is no longer even technological, although there is some risk there. Their major risk, from what I hear as a member of this committee, this subcommittee, the major risk is regulatory. They need certainty. They need to know that when they develop these technologies, there's not going to be a government entity out there that says, no, you can't launch, or no, you can't do that mission. And these are the challenges that we, I think, need to be addressing and looking at. When you think about remote sensing, NOAA has the authority to license, remote sensing satellites. When you think about communications, the FCC has the ability to license communication satellites. But those three missions that you specifically mentioned, these are non-traditional kind of missions that we haven't been doing commercially yet. And yet, right now we're raising capital. I say we, private companies, are raising capital to do these missions, and we need some kind of regulatory assurance that when they are ready, that there is nobody that's going to put the halt on their efforts. So thank you for bringing up those, and of course I think your vision for cislunar space is critically important. I'd like to the question I'd like to ask goes to, and I know a number of other people have touched on this, but I want to be really clear. And I know, Mr. Young, you're not here representing the NASA Advisory Council. I know you're a member of it, but you're here operating independently. But the NASA Advisory Council warned that NASA runs the risk of squandering precious national resources if they move forward with the asteroid redirect mission. Later, the NASA Advisory Council unanimously adopted a finding that it thinks NASA should change the asteroid redirect mission into a mission that would go all the way to Mars and thus be more closely aligned with the goal of sending humans there. Mr. Young, 2 years ago, you went as far as to say that the ARM proposal, quote, dumbed down NASA. Mr. Spudis, your testimony states that quote, ARM offers few scientific and scant operational benefits, unquote, and that, quote, in terms of scientific and operational importance, it is barren of real accomplishments and irrelevant to the future human deep space missions, unquote. Dr. Summerer, your testimony highlights that the NRC panel that you participated in found that NASA's current plans, which include ARM, have, quote, serious deficiencies with regard to the significance of intermediate destinations, logical feed-forward, dead-end systems, and exceedingly high development risk, unquote. That is not good testimony regarding the asteroid redirect mission from any one of you. My question is really simple. Why? If there's this much consensus, why is the administration still trying to force this mission on NASA, the scientific community, and the American public? And I'd like you guys to speculate on that, if you would. I have 1 minute left, and I'll just leave it to each of you. I'll start with you, Mr. Young. Or you guys can decide.
Fairly early in President Obama's administration, he said, not going to the moon, we're going to an asteroid because we've been to the moon. We did not actually have the capability to go to the asteroid for the foreseeable future for reasons that we've discussed. I think it is likely that that's an embarrassing position to be in, although I don't know what it's like to be president. And there were some people who came up with an idea that sort of got astronauts into the business of playing patty cake with something that came from an asteroid, at least, and that seemed very attractive. But I agree with all of the statements that I think it's a mission which has no real purpose, especially in the context of deep space exploration.
Mr. Young, did you want to add to that?
No, I think I basically agree with the comment. I don't really know the answer to your question, obviously. The reason for my comments and the other comments is that, again, I feel so strongly that we need to be doing those things that are critical to a successful human to Mars program. And this, in the mission, the asteroid retrieval mission, is far below threshold as to a mission that contributes to that endeavor, in my view. And again, to come back to what you meant relative to NAC, one of the things that's argued is, well, out of that mission, we get some technology, and the technology is on the solar electric propulsion tug. And I think that's true, and the SES technology is needed. So do that technology. Don't encumber it with all of the other activities that's there. And I think that's why the NAC said, look, a terrific thing would be take an SES, fly it to Mars, bring it back, and demonstrate the technology in a manner that it'll ultimately be used relative to Mars.
And I'm out of time. Mr. Chairman, in closing, I would just like to say that going back to my original statement, as these private companies are raising capital and they're retiring technological risk and they're ready to launch, we need to make sure this committee is 100% committed to enabling and allowing them to do what they've what they're supposed to be doing, which is advancing the human condition with commercial and private sector capabilities. So thank you so much.
Yes, sir. Thank you, Mr. Bridenstine. Mr. Posey, the gentleman from Florida, is back in here, and so I'd call on him for a line of questioning.
Thank you very much, Mr. Chairman. Dr. Spudis, in your testimony, you state that the United States abandoned the strategic goals for space set by Vision for Space Exploration in 2010 and eliminated the objective of a lunar return. The elimination of lunar return has left a vacuum in the national space exploration policy that has yet to be filled. Should the United States return to the moon and assist lunar space, and if so, how does that fit, in your opinion, within a longer-term human exploration strategy?
Well, yes, sir. I do believe that the moon played a critical role in the original vision for space exploration, in that it was a key enabler. It both enabled you to create the technology you needed to go deeper into space beyond low Earth orbit, and it also offered the ability to create all new capabilities, such as the provision of consumables and propellant from lunar materials. So for this reason, I've advocated lunar return for a long time. The more we learn about it, the more promising it appears as a target. And you have to be able to build a system in an incremental manner using small steps so that you don't necessarily have a big wedge of money that you need to get started, but at the same time you create long-term capability. So in my opinion, focusing on the development of cislunar space and specifically development of the resources of the moon actually can create new capabilities that we currently don't have, and that includes the capability to go to the planets.
Yeah, virtually, and I may have forgotten some who didn't, but virtually every witness we've ever had come before this committee has said we need to have a lunar base as part of the stepping stone. The only one we haven't got that yet from is NASA. Dr. Spudis and Dr. Summer, can you discuss what are the most important elements of the planned cislunar habitat that feed into the longer-term plan for the journey to Mars? What key technology development and scientific research can be done there that will feed the forward to a human mission to the Martian system?
One of the salient features of a mission to the Martian system is how long it takes, given our current propulsion capability and those we foresee. It could take years, okay, at least a year. We've learned a great deal about environmental control and life support systems as part of the ISS. However, and I have this on authority from the engineers who are responsible for that, it's kind of a kludge. There's a lot of things that have been put together over time. They aren't totally compatible. You would, I would think, if you're an astronaut on your way to Mars, want to believe that that environmental control and life support system was going to be very reliable, not require constant maintenance, and was going to get you there safely. That's one of the things that you could do in cislunar space. You could develop that capability in cislunar space where you're only 3 days away from help if something does go wrong. That would be a very, very important contributor to Mars. The other thing that you can't do on the ISS is deal with galactic cosmic rays because it's at such low altitude and deep in the Earth's magnetic field. We need to have a lot more experience with what radiation does to people on long-duration missions. That's something also that can happen in cislunar space where people are pretty close to help if things are going badly.
Yeah,
Those are two things that I think are absolutely critical.
You know, I'm a son of Apollo. When they did all that without computers, they did it with slide rules. You know, as President Kennedy said, great nations do things because they're difficult, because they're hard, actually. He said, not because they're easy. And certainly this falls in that ballpark. Dr. Spudis, it's my understanding that commercial lunar mission backed by private sector investors could be launched to the moon as early as next year. As an advocate of lunar resource development, do you see value in commercial robotic missions, and do you think NASA could benefit from including payloads on those missions?
Yes, I do. And I should preface this by saying I'm involved in one of those commercial companies. I advise Moon Express Incorporated on possible payloads. But in actual fact, there's a lot that you could accomplish with small robotic missions to help prepare the way for both human return and the development of lunar resources. For example, if you were able to fly a set of instruments that could measure surface hydrogen on a small lander and land it near the lunar poles, that is a key critical piece of strategic information that we don't have. It would also allow us to calibrate the remote sensing data that we have. I think it would be a very good investment of NASA funds to help provide instruments like that to any of these commercial missions for the simple reason that it's a cheap and inexpensive way to get very valuable long-term strategic information.
Okay, and for you and Mr. Young, as seen with the success of the commercial cargo program and the progress being made with the commercial crew program, can you discuss in more detail how NASA can leverage public-private partnerships as human exploration program extends beyond the low Earth orbit?
It's a broad question. As I said earlier, industry is a critical component of the exploration program in partnership with NASA. The commercial activity, I'm going to use commercial cargo as an example. In that particular circumstance, NASA or the country has turned a lot of the responsibility over to the commercial supplier. And I think in that instance, it was a good thing to do. and it was a good decision. I think we've got to be careful when we talk about exploration as to how we use the term commercial. And what I really mean by that is I think it's going to take the best of NASA, the government, and industry to do a human to Mars mission, and we should not do commercial experiments as a part of that endeavor. So I don't know whether I've specifically answered your question or not, but I think there's a spectrum where commercial makes, the real term commercial makes an awful lot of sense, and there are other activities where the nation has to provide the leadership from government with industry being an implementing partner to make things happen. So that's what I was trying to say. If I could, I know I'm cheating, but if I could make one comment on cislunar space that you talked about, I think there are things, and I agree with the Kennedy statement, which I think was good, but I think there are things that can and should be done in cislunar space that are necessary in order to have a human to surface of Mars mission with an acceptable probability of success. However, my caution would be we don't need another space station in cislunar space that is basically going to be carrying on an R&D program there. And I think that was your implication also. So I think that, again, the plan we keep talking about will allow us to make the judgment as to, in cislunar space, what is required, and we need to separate that from what we can do there, because what we can do is probably not necessarily what needs to be done. So I think cislunar space needs to be planned very well, or it itself can become an enormous user of this resource that we're talking about.
Thank you, Mr. Chairman.
Yes, sir. Great line of questioning there. Now I'd like to recognize the gentleman from California, Mr. Rohrbacher.
Thank you very much, Mr. Chairman, and thank you for holding this hearing. I'd like to identify myself with the comments of Congressman Brooks and Bridenstine earlier. They made some very good points, and I'd like to also identify with our witness, Mr. Is it Spudis? Is that how I pronounce it? Okay, Mr. Spudis, who is admonishing us to do things incrementally because it's affordable and getting something accomplished, as compared to laying down a 20-year program of gigantic spending that will suck the money away from all the other projects that NASA comes to mind in the next 20 years. In the next 20 years, I'm sure we will have lots of great ideas that may be more important than spending money on getting a man to the moon, to Mars, and planting a flag and coming back. In fact, if the Mars mission is to be successful, it appears to me that we need, if we were to say our goal is to have an American on Mars, we need to ask for volunteers and say, you're not coming back. That's the only way that would be affordable, and that's just a thought. In terms of the greatness challenge, I agree with you. America needs to do great things, and we are doing great things that inspire young people. We now have a reusable rocket system and are being developed, and that came from the private sector. And we have, Virgin Galactic about ready to make suborbital space a major part of Americans and Western civilization, because it's going to be spread us all over the world in a matter of minutes. These are great things that these young people are going to be able to participate in that didn't exist before. Blue Horizon, SpaceX, Virgin Galactic, they're doing great and historic things. Let me just note that if we do decide, and it looks like the argument keeps going, go to Mars, I've heard this for 20 years, it looks like that's what people are forcing us into this mode of spending. 10 years down the road, if we have committed ourselves to so many $1 billion every year that we're spending, and we end up spending $20 billion, $30 billion down the road, and let's say at that point, a meteorite, instead of like skimming Russia like it did in 2013, a meteorite would hit a city and kill hundreds of thousands of people. Can I tell you what that would do to the priority of space spending for this body? They would cut everything off, because then the public would demand that we were spending our money on global defense rather than on planting the flag on Mars. And all of that money that we'd spent then would have been wasted. That is, what I just described is not a scenario that will never happen. It may never happen, but it could well happen. There's nobody in this room who believes that that might not happen in the next 20 years. So let's make sure that we do things incrementally, so when we are spending, at least if we do have to change spending priorities in the future, all of that money won't be wasted, won't be right down the toilet. We can't afford to do that, as Mr. Brooks pointed out. We can't afford to waste billions of dollars. We just can't afford that. It will bring us down as a country rather than uplift our country, which is what the space program is supposed to do. So I would suggest that maybe we need to calibrate our plans. We have global defense, which I just mentioned, is really an important thing. Clearing space debris. Pretty soon we're not going to be able to use space unless we actually initiate a program that's going to clear the space debris that will, again, when we're talking about our young people, they're used to now living in a world where we have GPS and we have telephones and we have all sorts of utilizations of space. And unless we start clearing that debris, there's going to be no more ideas about utilizing space, because there won't be any space up there to do this. They'll be filled with debris. So we have these challenges, and I would just hope that as we're discussing manned missions to Mars, that we keep in mind that if we end up defunding all these other programs, it'll bring us down. It'll bring the American space program down. So with that said, let me ask about the moon. I guess I'm already over, I'm sorry. But, and by the way, Mr. Chairman, I was the chairman here of this subcommittee years ago, and frankly, we had to force NASA to go around the moon by the poles in order to find out if there was going to be water or not. We had to basically force NASA to do that. They did not want to change the pattern of just going around parallel. Give us and you already mentioned this in passing, give us an example. Again, if we have water on the moon, and we've expanded, now we know there's considerable water, that will permit manned presence on the moon, and will then also permit us to further manned use of space beyond the moon. Is that correct?
Yes, sir. Effectively, the moon has two resources to offer at the poles. One is the water, which is in the form of the deposits of ice that have been stable for billions of years. And apparently it's present in massive quantities. At least if the estimates from our remote sensing are correct, there are at least hundreds of millions of tons. I personally think there are over billions of tons. The second thing you have that's critical are zones on the moon near the poles which are in near permanent sunlight, which allows you to essentially stay on a sustainable basis on the moon. Now, water is useful both for sustaining human life. You can drink it, you can use it for sanitation, you can protect yourself from radiation. But more importantly, it's the most powerful chemical rocket propellant we know of. If you split water into its component atoms and then freeze that into a liquid, you've got liquid oxygen, liquid hydrogen, which is basically what the space shuttle main engine uses. There's enough ice at the poles of the moon to launch the equivalent of a space shuttle every day for over 2,000 years. So that's a lot of water. You're not going to run out of it soon. And if you're able to access it and process it and store it and send it into space, you've actually created a fueling depot that will allow you to go to Mars on a sustainable basis.
What would the cost, and we're talking about, we just mentioned the cost of going to Mars. What's the cost of what you're talking about?
It depends on how you approach it. And a lot of people have published ideas on this. I have published a paper on it. There was another paper this past summer. But I certainly think it's less than $100 billion. The key is to use robotic assets to get started, and then use people as they become necessary. So you can do this on the moon. You can't do it on asteroids. And you can't do it on Mars because the moon is close. So you're able to remotely control robots via teleoperation from the Earth, and you can't do that on the more distant targets.
Well, I just note, Mr. Chairman, when I talk about the potential of our space commercial sector and space refueling is also something they could do, maybe not from Mars. And again, a private company might want to put up a space refueling station, and that would enable us perhaps to bring down the cost for space exploration and also for moon missions. And one last thought, and that is, sorry, I really think Elon Musk is going to be on Mars before NASA gets there. And just a thought. Thank you.
Thank you, Mr. Rohrabacher. I'd like to recognize the gentleman from California, Mr. Knight.
Thank you, Mr. Chair. You know, there's been a good discussion here today. I think that a lot of this does revolve around money. I think much of it revolves around technology. I think that Mr. Perlmutter might want to change that bumper sticker and just the first number. You don't have to change the second number, but the first number in the years there. It's not going to be 2033. We are way a ways from going to Mars and getting back. We can go to Mars, but getting back is going to be a problem. I think that one of the discussions about Apollo 13, when you're 100,000 miles away, it's a lot different than when you're 25 million miles away. There is no help at 25 million miles, so that is a distinct problem that Americans probably will not take for their astronauts to be in that kind of peril anytime soon. The second thing is money. If we're going to spend $12 billion on this over the next 15 years or 17 years to get us there, that will be a issue. Right now, NASA only spends about 3% of their budget on aeronautics. And I have complained about that, and I'll complain about that as long as I'm in Congress. I think that that is criminal, that we spend 3% of our budget on aeronautics. When a lot of the products that comes out of NASA is for us right here, either in general aviation or in commercial aviation, and we still only spend 3%. We've been working on scramjet technology for 50 years. We are still working on that. We are still a ways away from that. And I think that that technology is part of a big problem. But I have a question. And that is on the lines of the experiments we've done in the space station, and one of the experiments that's happening right now with a twin on the ground and a twin at the space station for a year. Do any of you believe that at this point we can say that safely a man can travel or a woman can travel to Mars and be returned to Mars in maybe a 2.5-year mission? And with what we know today, do you believe that that is doable, feasible? Not doable that, yes, we will get something back, but that that person will come back.
I think it poses a significant risk based on what we know. NASA actually has a pretty good human research program, but given the resources that they're dealing with, there are significant uncertainties about what the microgravity and the radiation impact, to say nothing of the chemical hazards that Mars might do to the health of astronauts.
My second question, I think you hit on it earlier, is the propulsion. Our propulsion hasn't changed in many, many years, from basically the beginning of rockets. It's going to take us about a year to get to Mars today. Do you see over the next 15 or 20 years some sort of propulsion system that is going to speed that up dramatically so that we can get to Mars in maybe a less than 6-month period?
Certainly, I don't see it happening if we don't work on it.
And I would make that statement to everything. If we spend the money and we work on it, I believe that the American ingenuity can do this. I believe that we can do this in that time period. I don't think that there is a there is a push to do it, and I don't think there is a push to do it consistently. And Mr. Rohrabacher talked about an awful lot of programs that, and Mr. Young talked about the headstones in the cemetery. I believe that, but I also believe that you get things from that. There was a program in the late 50s and early 60s called the X-20 Dinosaur. I think that that was the first space shuttle that we would have ever built, and it would have been very successful. We abandoned that program for lack of a mission and for funding, and we wanted to send a man to the moon. I think that we learned an awful lot from the X-20 Dinosaur, and I think if Jeff Greason from X-Corps was here today, he would say we learned an awful lot, because he's building something that is very similar to the X-20 Dinosaur. So just because a program was canceled, or just because a program never left the launching pad, doesn't mean we didn't learn something from it. It doesn't mean that that money might not have been well spent. But I will agree with Mr. Rohrabacher. If we don't use the program and we spend hundreds of billions or tens of billions, the taxpayers do feel at a loss. So I think that NASA can do anything that they put their mind to and anything that we can fund. Thank you, Mr. Chair.
Yes, sir. Thank you, Mr. Knight. I think this has been an excellent exchange of ideas and from you expert witnesses. We really appreciate this, and because there's a great deal of question marks out there about what we're going to do and the missions we're going to have. And the old saying, do we have guns or butter, or guns and butter? And obviously today, all three of you, if I'm reading you right, say it's got to be either guns or butter in this situation about whether we go to Mars or back to the moon. And we have our work cut out for us. And I agree that whatever NASA puts their mind to, we can do. But we do have the parameters of a almost $20 trillion national debt that we have at this point in time. But I think with what we gain from our space program, it is, and great, as you said a while ago, Mr. Young, great nations do great things. So I think we have our marching orders. We just have to get organized on this. So I just want to say thank you to all three of you, and thank you for the audience out there, and thank you for this line of questioning. And so I adjourn the hearing.
This is because of the importance of defining a baseline architecture and plan that encompasses the entire human exploration program. Mr. Chairman, I'm confident that a plan of sufficient detail can come to fruition, but we don't have time to spare if we're to sustain a challenging endeavor across the upcoming presidential transition. Now it's time for us to get rid of the politics and actually match our goals with a plan. And without agreement on the substance of a plan, the path forward is less clear and the sustainability of progress toward the Mars goal is left vulnerable to rehashing of interim destinations or even redirection. We've seen that happen in the past. This last decade, despite the concerns articulated by the chairman, this last decade has been fraught with confusion, both from the Congress, Republicans and Democrats, and Republican and Democratic presidents. And it's time to put that aside so that we can advance the science that's necessary. And make no mistake, we have to do our jobs here in Congress, and we have to be of a mind in providing NASA with the necessary resources and budgetary stability to carry out such a plan. The Congress's recent increase in appropriations for fiscal year 2016 for NASA's exploration systems is a good start, but they need to be sustained and built upon if we're to reach that goal. So, Mr. Chairman, we have a lot to discuss this morning, and I look forward to our witnesses' testimony. And what I would urge us to do is, again, let's just put the politics aside. I agree with the chairman that going to space is not about Republicans and Democrats. And when I look at these young people out here and I see your future and I see the challenge that you're going to take on, you don't care whether it's a D or an R. We care that we advance the science to get us to our goal, and I look forward to doing that. Thank you, Mr. Chairman, and I yield.
Thank you, Ms. Edwards. I appreciate those words. And also would like to welcome all you young folks out there, as well as you not so young folks. We understand, are you all from Florida? Yes. Well, thank you for being here this morning. What you say?
Where's Bill Posey?
Louisiana. Okay, well, that's good. Almost to Texas. And speaking of Texas, I now recognize the chairman of the full committee from the great state of Texas, Mr. Lamar, Chairman Lamar Smith.
Thank you, Mr. Chairman. Americans are fascinated by space exploration. It fuels our desire to push the boundaries of what is possible and to reach beyond our own pale blue dot. In the last few years, the flagship deep space exploration programs at NASA, both robotic and human, have been under attack by the Obama administration. This administration canceled the robotic ExoMars mission and the Constellation program, and it continues to propose drastic cuts to the Space Launch System and Orion programs. These programs were all developed to support deep space exploration to destinations like the Moon and Mars.
The policy experts, scientists, and engineers, the administration as recently as last week announced early design work for the asteroid mission spacecraft bus. With only 9 meaningful months remaining in this administration, it is puzzling that they continue to press ahead with the mission despite widespread criticism and doubt over its efficacy. The National Academy of Sciences released a study on human exploration called The Pathways to Exploration. In this report, the Committee on Human Spaceflight determined that the ARM mission largely contributed to dead-end technologies that could not reasonably feed forward into the human mission to Mars. Last year, the NASA Advisory Committee suggested to the administration that a more valuable use of NASA's time and money would be a solar electric propulsion demonstration mission to Mars and back, as opposed to the asteroid mission. Alternatives to the asteroid mission proposed by the President have become ubiquitous in the policy discussions. For example, Jan Werner, the European Space Agency Director General, has spent the last year advocating for an international lunar base. The recent Humans Orbiting Mars workshop presented a compelling, realistic, and affordable path to Mars. Also, several members of this committee have suggestions and legislation as well to that effect. As the administration ignores these proposals despite a groundswell of support from scientists and engineers, we must look beyond what is politically expedient today and to get ready for the next few decades in space flight. As we prepare for the next president's administration, we must ensure that the plan in place for human exploration is based on sound engineering, planning, design, and management principles. We have asked our witnesses today to give us their expert opinions and the way forward. This hearing is an opportunity to build consensus on the way forward for human spaceflight. Human exploration has a long and storied history of being nonpartisan. It is not Republican. It is not Democrat. It is an American issue. We need to get the politics out of these very important programs for our nation's sake. There are thousands of men and women in this country whose days are impacted by the decisions that we make in this very building. It is easy for people confined to the Beltway bubble to forget that our pride as Americans comes from the hard work and determination to make this world better. The men and women at NASA working on our human exploration program are not pawns to be moved around a chessboard in the latest game of chicken that the administration chooses to play with Congress. We must ensure NASA's work focuses on the will of the people, not the political whims of whatever president is in office.
The Obama administration cannot claim that it prioritizes Mars exploration if it refuses to prioritize and support the programs that will get us there. And the budget instability created by the administration makes it hard for NASA to plan and execute critical programs. For example, NASA recently announced that the first crewed mission for SLS and Orion was now delayed by 2 years because the administration would not allow NASA to budget for the programs. While the administration regularly cuts SLS and Orion budget requests, Congress continues to restore those cuts in a bipartisan fashion. And there is bipartisan support within Congress for SLS and the Orion crew vehicle. This committee has restored proposed cuts year after year in our authorization bills. And the House and the Senate Appropriation Committees restored funding for the SLS and Orion at the levels necessary to keep their development on track. The SLS and Orion programs represent what is most impressive about the American spirit, the desire to explore. The technologies that are developed for these programs exemplify our greatest breakthroughs and demonstrate American ingenuity. This committee will not permit this administration to threaten the succession of these programs. Any efforts to cancel these programs will be met with stiff opposition. The administration should develop solid plans for future exploration missions that foster support from the science and engineering communities. However, the administration continues to push plans for an uninspiring and unjustified asteroid retrieval mission. Just last week, NASA announced its strategy to develop the spacecraft bus that will be used for the robotic elements of that mission. The administration continues to force this mission on NASA without any connection to a larger exploration roadmap and absent support from the scientific community or NASA's own advisory committees. This is a misguided mission without a budget, without a launch date, and without ties to exploration goals. It is a mission without the support necessary to make it a reality in the 9 months remaining in the Obama administration. It is just a time-wasting distraction, but maybe that is what the administration really wants. Instead, the administration should follow the advice of the NASA Advisory Council and more fully develop its human exploration plans, including a human flyby mission to orbit Mars. There are many options, but without a roadmap to guide the agency, NASA will continue to be subject to indirection and proposed budget cuts by the White House. For its part, Congress will continue to ensure that space exploration will receive the funding needed to stay on schedule and on budget. Great nations do great things. Fortune favors the bold. These next few years are critical. A trip to Mars can turn science fiction into science fact before our eyes and within our lifetimes. The first flag to fly on the surface of Mars should be ours. I hope the administration will join Congress in pursuing that.
At that particular time, NASA's human exploration program has been through a tumultuous 7 years. And with a new president to be chosen by the end of this year, we must ensure that there is a constancy of purpose in our planning and a sure-footed roadmap in place for the future. I now recognize the ranking member, the gentlewoman from Maryland, for an opening statement.
Good morning, and thank you very much, Mr. Chairman. I want to welcome our distinguished panel this morning. This truly is my passion. I want to thank Chairman Babin for calling the hearing. I think it's really important. And when I look at the young people out here, not only is it my passion, but it really is your future. And so I think the work that we have to do today is incredibly important. Each time we hold hearings on sending humans to Mars, my colleagues and I don't just leave the room, although today I will have to leave a little bit early. We don't leave the subject behind, and I think that that is meaningful for the American people. Instead, we leave with increased determination to help find a way to get there as soon and as safely as possible. I want the American people to share the collective excitement in this room and to embrace the desire to send human explorers farther into space than ever before. This committee's inquiries during recent hearings have focused on the need for a clearly articulated plan and next steps, such as the Human Exploration Roadmap that the bipartisan, overwhelmingly bipartisan House-passed NASA Authorization Act of 2015 directs NASA to develop. It took a lot of work for all of us to come together as Republicans and Democrats to embrace that roadmap. I recognize that it's not an easy task given previous flat funding levels, uncertainty over future budgets, and the need to allow flexibility in planning a multi-decadal endeavor. I also acknowledge that NASA has established a strategy for achieving the goal and an evolvable Mars campaign that will allow for flexibility in its decisions and that can take advantage of new knowledge and advances in technology. But facets of that strategy, quite frankly, are not detailed enough to inform mission planning and sequencing. That strategy cannot answer questions about whether going to the lunar surface or an asteroid is needed to reduce risk before sending humans to Mars. Nor does it allow us to assess whether NASA's approach achieves the right balance of flexibility and definition. The congressionally mandated National Academy's report, Pathways to Exploration, recommends that NASA follow a pathway, a specific sequence of intermediate accomplishments and destinations that advance the technologies needed to reach the horizon goal, which they conclude is Mars. The NASA Advisory Council, in its December 3, 2015 recommendations to the administrator, said that they were pleased that NASA was providing new information about its human exploration architecture. However, they also recommended that, quote, in preparation for the 2017 transition of administrations, NASA further develop their plan for future human exploration.
Okay, the Subcommittee on Space will come to order. Without objection, the chair is authorized to declare recesses of the subcommittee at any time. Welcome to today's hearing entitled Charting a Course, Expert Perspectives on NASA's Human Exploration Proposals. And I would like to recognize myself for 5 minutes for an opening statement. Placing a man on the moon and returning him safely is widely considered one of humanity's greatest achievements. It cemented America's leadership on the world stage and demonstrated our technological superiority during the Cold War. Since then, NASA has made steady progress towards learning to live and work in space with the Space Shuttle and the Space Station. Today, we find ourselves at an intersection. Do we as a nation retreat from the cosmos, or do we take that next first step into the unknown? There appears to be a consensus that the horizon goal of America's human exploration program is to land on the surface of Mars. But how will we get there? What are the intermediate stepping stones on that pathway to Mars? How do we avoid costly and avoidable detours? How do we ensure a sustainable program rather than a one-off stunt? And how do we ensure the next administration does not wipe the slate clean, erasing all the hard work of the last 5 years? These are all questions that we must address in this and in future hearings. The SLS and Orion systems are critical to the success of our deep space human exploration program. Their development and testing is of the utmost importance to the committee, to Congress, and to the nation. We have come too far now to see a costly and destructive cancellation. However, the use of these assets and the missions and mission sets on the journey to Mars need to be better defined. As the NASA Advisory Council recently stated in a recommendation to the administrator, the absence of a more fully developed plan would impair the ability of the next administration to propose a budget that adequately supports NASA's human exploration program. And while the administration has not provided many details on the plan for the journey to Mars, it has proposed possible mission options. For example, the administration has proposed an asteroid mission as the next step for human exploration. This has been caveated and altered multiple times, but generally speaking, the administration believes human astronauts should interact with an asteroid in cislunar space sometime in the next decade as the next step on its journey to Mars. Despite opposition from space